Welcome back to Why This Universe. Today on our show, we're going to talk about a really exciting and honestly very surprising discovery from cosmology lately, one that has completely shaken up the grounds of what people believe to be true about the universe. So let's get right into it. Stick around. You're listening to Why This Universe, a podcast where we break down the biggest ideas in physics. I'm Shalma Wegsman.
And I'm Dan Hooper. We've been doing Why This Universe now for almost 4 years. We put out about 80 episodes on all sorts of different topics across physics, astronomy, and beyond. But in those 4 years, we've never been able to put out an episode about a discovery that's quite as big and as important as the one that we're going to talk about today. So it's a very exciting episode. Just last week, I think it was on Tuesday, a consortium of astronomers reported that they have observed a bunch of different stars in a lot of different galaxies that were moving along trajectories that it seems, simply isn't consistent with the kinds of motion that are predicted by our standard cosmological theories. So in those standard cosmological theories, the gravity of galaxies is dominated by dark matter. And these stars, they're just not moving in a way that dark matter could cause them to move. For the record, I just, to be clear, this is super surprising to me, like all the way to 10, maybe 11 in the surprising scale. And it's really surprising to pretty much all of my colleagues. This is not what we were expecting. But the data looks pretty clear, and it seems that dark matter just can't exist in light of this data. It doesn't exist after all. The phenomena that we've long attributed to dark matter, it turns out, is instead the consequence of us misunderstanding the force of gravity. In other words, what these astronomers seem to have discovered is that some kind of MOND, short for modified Newtonian dynamics, is the correct theory of nature.
Okay, Dan, so this is, your whole career has been kind of centered on the theory of dark matter and looking for it in all shapes and sizes. This must be a huge blow. Do you have a retirement plan? What are you going to do?
Yeah, way to rub it in, Shalma. Yeah, you're right. I would have bet a lot of money against this result. Okay, this seems, for years I've just argued this is totally implausible. But you know what? Whatever my opinions are, I'm deep down, I'm a scientist. When the data says something as clearly as it does in this case, I don't have any choice. I have to revise my opinions and accept truth for truth. And as unlikely as I've, long, for decades considered MOND to be, it seems that it's the right theory after all.
Okay, so let's not get ahead of ourselves. So there might be some listeners who have never heard of this theory of MOND. So let's give a brief description. What is MOND exactly?
Yeah. So MOND is an idea that goes back to the early 1980s. The first papers were written in 1983 by an Israeli physicist named Mordechai Milgram. So at that time, there were some pieces of evidence for what we at the time thought of as dark matter. And a lot of that had to do with how stars and gas orbited around galaxies. So Milgram pointed out that there are two ways you can interpret this data. Either there could be a bunch of extra matter causing the things to move the way they did, or it could be that the laws of dynamics, the stuff, the laws of physics that determine how things move could be different. So he took the first equation you learn in physics 101, F equals ma, force equals mass times acceleration. And he said, well, that's true so long as the accelerations are kind of big. But when the accelerations get really, really, really small, as they would for stars moving on the outskirts of galaxies, then the law kind of transitions from F equals ma to F equals ma squared. And if you do that, then you can make galaxies behave the way we observe them to without any dark matter. So this became known as MOND. There are a bunch of different versions of MOND, and right now we don't know which version is right. Just some sort of version of MOND seems to be right. And the data we're looking at now is a whole bunch of different stars and a bunch of different galaxies. Many more stars, much more detail than we've had before. And they look like what you expect from MOND and not what you would expect from a universe that's made mostly of dark matter.
I see. So I understand this is a really extensive survey that we're seeing now of more stars and more galaxies than we've seen before. Right. Yeah. So up until now, dark matter and MOND were kind of two competing theories that could both explain the motion of galaxies, but now we're seeing this data suggesting that with a more precise measurement of the motion, it actually matches MOND and not dark matter. So can this data really differentiate that well between the two theories?
Yeah, for a long time, people have said that, the MOND and dark matter could both explain any amount of galactic dynamic data. Like, we didn't expect that to be the thing to settle it. But it turns out that this data is just so abundant and so high quality that it can actually do it. So it looks like it's like a total smoking gun now. All the experts who have looked at it seem to say that this looks just like what MOND predicts, and they can't fit it to any kind of dark matter, it turns out.
Wow. I mean, that's amazing. I mean, I had also understood up until this point that there were other kinds of evidence that were ruling out MOND. So how do you explain, for example, the temperature fluctuation in the cosmic microwave background that we had previously attributed to being a sign that dark matter was a better theory?
Yeah, I mean, a lot of people, including me, have been saying stuff like this for years or even decades. Like, I think on this podcast, we've probably said that the patterns of temperature fluctuations and the light left over from the Big Bang, this cosmic microwave background, are consistent with there being a lot of dark matter in the universe, but are not consistent with any kind of MOND that had been written down. Like, that's something you hear a lot. And like, the overturning of that is maybe the most incredible part of this story. So I'm going to go a bit back to the 80s I think it was 86 or something really close to it anyway. This group of really famous like cosmologists. I won't say their names because, I don't want to embarrass them right now, but like some of the top names in cosmology, people from Princeton, Harvard, Stanford, they worked out in detail what they said the cosmic microwave background should look like if our universe contains a lot of dark matter, and also what it should look like if some sort of MOND was instead the right theory of our universe. And when the data was collected years later, with experiments like Boomerang and WMAP and stuff like this, that data was compared to the predictions of that paper, and that comparison showed that dark matter had to be the right answer and MOND was ruled out. But just recently, probably motivated by this recent announcement we're talking about today, people went back and kind of scrutinized that old paper from the late 80s, and they found a mathematical error. So, I mean, lots of papers have errors. It's not that uncommon. But this one's actually kind of embarrassing. There's a place where they are doing some arithmetic and it's kind of all under the hood, but they kind of forget to carry the 1 in this particularly critical place.
Yeah.
Yeah.
That will get you. And that's we've all been there.
Yeah. I mean, who hasn't done that at some point in their, their homework assignment or whatever? Yeah. It would have been great if they had caught it, but, here's what I'll say in support of these guys. They're coming clean now. Like this was brought to their attention, and now they've agreed to retract the paper almost 40 years after the original publication. And they seem to be taking responsibility, and they're trying to clarify the situation. And not everybody does that. Some people get caught in a mistake and they double down. These guys are being intellectually honest, so kudos to them. But, okay, the end of the story is the dust is still kind of all settling on all this, but it looks like among the cosmological community, something like a consensus starting to form that the observed patterns of the temperature fluctuations in the cosmic microwave background look to be consistent with lots of kinds of MOND you could write down.
Okay, I mean, that's incredible. So what about the other evidence against MOND?
Yeah, a lot of it seems to be kind of falling apart, kind of collapsing like a house of cards. Historically, one of the most important arguments in favor of dark matter over MOND is that the ratio of different, nuclear species, helium, hydrogen, deuterium, so forth, kind of gives us a way of measuring how many protons and neutrons are in our universe, how much dark matter there is in our universe, stuff like this. But it turns out, that a few months ago, astrophysicists discovered that they had missed like almost half of the total helium in our universe. That helium that they hadn't seen before, hadn't noticed before, is actually like all clumped behind stars. So the stars had been blocking it, making it impossible for the telescopes to see. Maybe we could have foreseen that, but I don't know. It seems like, it seems a little unlikely, but it turns out that's the answer. So when you take this into account correctly, it seems like there might not be all that much more matter in our universe than we can account for with ordinary atoms. So we don't need the dark matter like we had previously thought.
Right. So we thought we needed all this extra matter, but turns out it was just kind of hiding behind our line of sight through the stars. It was in clumps there, and we just couldn't see it. And now we know.
Now we know.
Okay, great. And so what about, patterns of the large scale structure in our universe? I had understood that dark matter played a big role in the way that structure developed and causing, our filaments and clumps of galaxies and stuff. So what about that?
Yeah. So this is another big part of the classic argument of dark matter over MOND. And basically what it comes down to is if you look at the patterns of galaxies and clusters of galaxies and things in our universe, and you compare them to what you'd expect from a universe dominated by dark matter or a universe in which something like MOND was true, it favored dark matter strongly. But a conclusion is only as good as the data you have. And it turns out that the key observations that were made in these galaxy surveys, one of the astronomers had accidentally touched the lens and put a smudge on it, leaving a smudge. So they did this over again with a clean lens. And now it looks exactly like what MOND would have led you to expect. So
he ate some oily chicken or something and stained the lens.
I didn't ask him what he was eating there. All right. Thanks everyone for indulging us. This has been a lot of fun. Happy April Fool's Day. Thanks, Shama. Thanks to everyone listening to Why This Universe.
All right. So none of that is true. There's no big MOND discovery. Dark matter is still our leading theory. And apologies everyone who was fooled.
Yeah. Happy April Fools.
Maybe one last thing. I think you owe an apology to all of those people who have emailed you and you've been dismissive.
Please don't send me any more email about MOND. Whatever. Just please, I'm begging you.
Well, I've got a favor to ask of you. Well, I've got a favor to ask of you. Well, I've got a favor to ask of you.
Thank you for listening to today's episode. That was Stop Emailing Dan About Mond, a song by The Spectral Distortions featuring our very own Dan Hooper. Our show is produced by me, Shalma Wegsman. My co-host is Dan Hooper, a professor of physics and astrophysics at the University of Chicago and Fermilab. If you like our show and you want to support us and get access to ad-free episodes and Ask Us Anything exclusives, you can follow us on Patreon for as little as $3 a month. And if you're interested in that, you can go to patreon.com/whythisuniverse. We also have merch available that you can check in the link in the show description or on the Patreon site as well. Why This Universe is a part of the University of Chicago Podcast Network.